Hello and welcome back to Tech Construct. This video will be a part of a series which will be explaining design patterns in detail. To start, design patterns are simply blueprints that are used to solve common problems that we encounter every day in programming. For this video, we'll be focusing on a pattern known as the builder pattern. The builder pattern is what's known as a creational design pattern. A creational design pattern simply defines a blueprint for how we're going to create our objects. For the builder pattern, what we're going to do is create a blueprint that allows for a step-by-step approach for creating our objects. As you can see on the screen, I've created a class called Robot. That class has a number of different fields. For our constructor, we take in several arguments and we use those arguments to set the fields in our class. This class also has a method called printStats, which just prints all the values that our fields contain. On your screen, you see that I have a method called main, since I'm using Java for the sake of this example. Inside of that main method, as you can see on lines 11 and 19, I'm using our constructor and passing in the arguments needed in order to create our object. On lines 26 and 28, I'm going to be calling the printStats method, which will result in the following output. As you can see, we print out the name, the HP, its type, the primary weapon, and the secondary weapon. For Robot 2, we print in the same, except we also print out the support item since it has a support item. When we create a class, there's nothing to say that we can't add more fields, more methods to these classes. In the case of adding fields, let's for example say that I'm adding 3 new fields. I create a variable operational, which is of type Boolean, coordinates of type map, and status of type string. Now, in order to set the values for these particular fields, I'm going to need to update this constructor. But we'll also have to come back and update our constructor calls. Now, this is just one file. Imagine if you're using this robot class in 6 different files. You'll have to go back and update each and every one of them, else your code won't compile. Now, let's just say we have to add in 2 more fields for whatever reason. You're going to have to go through and do the exact same thing over and over and over again. Even worse is, some of these fields may not even be needed. A robot most likely has a primary weapon, but it may not have a secondary weapon. It may not have any support items. So how do we solve this problem? Our code has the potential to balloon out of control. Well, this is where creational design patterns come into play. In particular, for the sake of this video, the builder pattern. On screen, we have our same robot class. Inside of this robot class, I have a static class called builder. Our builder class has the exact same fields as our robot class has. Name, primary weapon, secondary weapon, support items, type, and HP. This builder class has a method for each of those fields. We have methods name, primary weapon, secondary weapon, support items, type, and HP. Each of these methods returns builder, which is just our class here. And each of these methods has one parameter. For name, we're expecting a string called name, and inside of this method, this .name is going to equal the name that we pass in, and we're going to return this. This, which just represents the current class that we're referencing. Each of the other methods follow the same pattern. The last method that we have is a method called build. This build method is what's going to create our object of type robot and return it to whatever it's calling it. So as you can see, return new robot, passing in all the fields that we have passed in to create our new object. On screen, inside of our main method, we're doing the same thing as before. On lines 9 and 17, you can see that I am creating 2 robots. On lines 24 and 26, I am printing the stats of those respective robots. This time, we're going to make use of our builder class. We have new robot.builder, since our builder class is static. And what we're going to do is, for every field that we want to set, we're going to call the corresponding method that is used to set that field. So I want to set a name, a primary weapon, a secondary weapon, a type, and an HP. On lines 10 through 14, we're going to make a series of method calls. On line 10, the .name references the name method inside of our builder class. Remember, the builder pattern allows us to step by step create our objects. On lines 10 through 14 are those steps. Step 1, we want to create a name for the robot. Step 2, we want to give that robot a primary weapon. Step 3, give it a secondary weapon. Step 4, give it a type. And step 5 will be giving it an HP. Once we've done all the steps that we want to do, what we're going to do at the end is call the .build, which is going to build that robot for us. The cool thing about this is we're not beholden to any order. As you can see with robot 2, our first step would be to set the type. The second step, the HP. The third is the name. And the final step is to set the support items. Note that we don't set a primary or a secondary weapon. And everything works just as before. As you can see our output, we print the name, the HP, the type, the weapons. We print our next robot, which has name, HP, type, no primary weapon, support items, and no secondary weapon. Now in the future, if we need to add some new fields, like how I've done on lines 12 and 13, I've created a new Boolean field called operational, and I've created a new string field called status. We would update our constructor to take in those 2 fields, and inside of our builder, we would do the same thing. We would add those fields to the builder, and then we would create methods in order to set those fields inside of the builder. And of course, we update our constructor call. Despite adding those 2 fields, our code doesn't break. Once again, imagine you're making use of this robot class in 10, 20, 50 different places in an application. None of those instantiations break as well. The reason being is, even though we've added some new steps that can be taken in the creation of our object, the simple adding of those steps doesn't cause our code to break all over the place. Inside of this class, I can add 20 other fields. It still won't break our code. The benefit that we gain from making use of design patterns like the builder pattern, which is, once again, a creational design pattern, is that we remove the responsibility of the creation of our objects from individual places in our code to just one place, and that's inside of the class itself. When I'm creating these 2 robots, we're only making use of the fields that we need. You could even do something like so. On line 24, I've created robot 3. And that robot, we don't take any steps. We just build and we take whatever we get. Since we have all of the responsibility of the creation of our object inside of just the class itself, what we can do is we can set business logic on top of the creation of those objects. So for instance, if the user doesn't supply a name, well, we can set up a default name. And that default name takes place everywhere that we're making use of this class. You can set defaults for each and every field if you wanted to. When we run our code again, robot 3, the name is null, the HP is 0, operational is false, type is null, and primary weapon is null as well. There are no support items either. What we've essentially done is whatever the default values for these fields are going to be, we just take those. To wrap things up, the builder pattern is a creational design pattern that allows for a step-by-step approach to creating our objects. The reason we use this pattern is to simplify the creation of objects of complex classes. Rather than having multiple different constructors that have differing sets of parameters, as you see on the screen here on lines 15, 19, and 23, we can simplify this by just having one large constructor that is used to build our objects. When it comes to simple classes, however, the usage of this pattern is far too excessive. For instance, if robot just simply took in a name, there would be 0 point to making this builder class. When you're dealing with a class that has 1 or 2 fields, it's simpler to just make use of a constructor. With all that being said, we've reached the end of this video. Hopefully this video has been helpful. I'm trying to experiment with different topics and different video lengths. With shorter videos, the hope would still be to be providing you with information that you find beneficial as you go about your coding career. Whether you're planning to make an actual career out of programming, or if you're a hobbyist. I want to make sure that these videos are still beneficial to you. But if you've made it this far, I would like to thank you for watching this video. Be sure to like, comment, and subscribe, and I'll see you guys in the next one. Take care.